Hello students, today we are going to solve a question from JEST 2020 and say basically part C, question number on. It's basically from optics. So in that question it is given that you have a water thin film, that is floated on silicone oil. Okay, and the refractive index of water is given. The refractive index of water is 1.33, that is given, and also given that the refractive index of silicone oil, that is given 1.40. Okay, and this thin film is illuminated by a light from top, and this is a normal incidence case. Okay, that light is incident normally, and the wavelength of this light is given, that is 600 nanometer. Okay, and it is observed that this thin film is appeared to be a red color. Okay, so what you have to calculate? You have to calculate the minimum thickness of water thin film. So you have a water thin film that is floated on silicone oil. The refractive index of water is given 1.33. The refractive index of silicone oil is given 1.40. That light having wavelength 600 nanometer, incident normally from the top. Okay, and as a result, this thin film is appeared to have red color. So you have to calculate the minimum thickness of this water thin film. Okay. Now see, this case is actually different from in general what we observe in thin film case. So as you have seen in other case, the constructive interference for thin film, that is like the condition is like twice mu t cosine r equals to lambda by 2 or 3 lambda by 2 or 5 lambda by 2 and so on. And that thing actually basically appeared when there is a reflection or when there is a reflection of light from a single denser medium. But in that case, that you will have that when that light is incident, some of the portion will be reflected from this interface. Okay, and this reflection I can think like a reflection is happening from denser media, because you have air here and this side you have water. The refractive index of water is higher than the air. So when there is a reflection from this interface, that will have that I can think like a reflection is happening from denser medium. So we'll have on extra phase that will be lambda by 2. And there's some of the light will be passed and it will be reflected from this surface. Again, I can see for this interface, I have to think that light is having a reflection because of silicone oil, and silicone oil is actually having a higher refractive index as compared to water thin film. So again, this reflection from this interface can be treated like a, it is happening because of denser medium. So we'll get another extra phase lambda by 2 from here also. So in ordinary case, when you have seen that thin film interface, will only get there is a two reflection is happening. From one reflection we used to get on extra part difference lambda by 2, because on reflection used to happen from denser medium and another reflection used to happen from rarer medium. As a result, there's an extra part difference is to come, that is lambda by 2. But in that scene you see both reflection is happening actually from denser medium, so both will give some extra path that will be lambda by 2 and that will be cancelled. As a result, here you will have that constructive interference condition that will be twice mu t cosine of r, that is no longer be lambda by 2 or 3 lambda by 2 or 5 lambda by 2 and so on, but यहाँ पे you will get that condition will be like that n lambda, and here n can take values like 1, 2, 3 and so on. Okay, so you have to use that concept because both reflection is actually happening from denser medium, so both will create some extra path that will be lambda by 2, and both will be cancelled when we will check that path difference between two reflected ray. So we'll not get that extra path difference here, simply we'll get that condition twice mu t cosine r equals to n lambda, and n can take values 1, 2, 3 and so on. Okay, so for normal incidence, as you know, for normal incidence, you'll have angle of refraction will be 0. As a result, twice mu t cosine 0, that is 1, equals to n lambda. And for minimum thickness, that n should have minimum values, and that will be 1. So obviously, you will get lambda. So minimum thickness t means minimum thickness of this thin film, that will be lambda by twice mu. Okay, and this lambda is given, that is 600 nanometer, divide by twice. Now mu, what is mu? Mu is the refractive index of thin film, because you are calculating, I mean, constructive interference for thin film here, so you have to take the refractive index of water thin film, and that is given 1.33. Okay, so 600 divided by 2 into 1.33, if you calculate, you will get 225 nanometer. So this will be the minimum thickness of water thin film to get red color. Okay, thank you.